Hello everyone and welcome back to another episode of
Science with Shriya.
In the last episode, we have talked about metals, metalloids, and nonmetals. Here is a review.
Metals are solid at room temperature, except for mercury. Metalloids have some properties of metals and some properties of nonmetals. Nonmetals are brittle solids, and nonmetals gain electrons easily.
All metals and some metalloids are good conductors of electricity, whereas all nonmetals are known as insulators, except for granite. Granite is the conductor. But you may have heard me say these words in the previous episode. What do they mean? An electrical conductor is an object or type of material that allows the flow of charge or electrons in one or more directions. Some examples of electrical conductors are iron, copper, gold, silver, and many more. But an electrical insulator is a material in which the electron does not flow freely, or charges do not flow freely. Examples of these materials are carbon, such as diamond, or materials high in carbon, such as charcoal, as well as synthetic materials such as plastic, glass, etc. Great, we can use conductors for energy to pass through it. But what about insulators? Insulators can be used to prevent the flow of electricity. For example, we have insulators around a wire so that we don't get an electrical shock. But do you know if you rub two insulators or one insulator and one conductor, you can get static electricity due to friction?
Let's say you woke up from bed and you were rubbing your feet on the carpet. During this time, electrons from your body transfer to the carpet. After this, the electrons stay static in the carpet, creating static electricity. However, Mother Nature always keeps everything in a balance, and when you touch a conductor, like a doorknob, to open the door, zap! The electrons from the metal doorknob go to your body immediately. When electrons flow from one insulator to another object, it is called static discharge. The reason why you get that zap is because you have now created electricity.
Okay, so now we can finally talk about what you clicked on this video for, to learn about electricity. Electricity is the flow of electrical charge through a conductor. A circuit is a closed path or a loop that allows electricity to flow from one point to another. And the rate at which an electricity flows through a circuit is known as current. A circuit is composed of at least three components: a power source, a wire or electrical conductor, and a resistor. Here is what an electrical circuit looks like.
For any circuit to work, you need an electrical power source. The most common electrical power source we use in science projects are batteries. Batteries convert chemical energy to electrical energy. Other common sources of energy are solar panels. Solar panels convert sunlight to electricity. Hence, solar panels are renewable sources of electricity. Other renewable sources of electricity are hydroelectricity from the flow of water in rivers, or wind power, where electricity is produced by blowing of winds, which are usually generated in big power stations or power plants, from which our homes get electricity. Many of these power plants generate electricity by burning fossil fuels like coal or natural gas, which are non-renewable sources of electricity. We should best avoid that kind of electricity to save Earth from global warming, which is a topic for another day.
An electric circuit needs wires so that the electrons can flow through it. However, if you connect the two ends of the wire to the two ends of the battery, there is nothing to block the electricity from flowing flowing, and we get a short circuit, which will heat the battery and can cause fire. Now, as cool as that sounds, we should never try that. So, the third component of a circuit is a resistor, which resists or blocks the electricity or uses the electricity for something, such as generating heat as in an electric oven, light as in light bulbs, or motion as in a fan. The resistance in a resistor is measured using the unit called ohms, named after a guy named Georg Simon Ohm. There is actually a law named after him called Ohm's law, which you will talk about a little bit later in this episode. Please note when I showed you this sample circuit with these three things, the battery, the wire, and the resistor, when they are connected, we get a closed path or loop for the electricity to flow, making the circuit complete and electrical current to flow through it. Electrical current is measured using the unit Ampere, named after the French physicist André Ampere. There is one last thing that you need to know, and that is voltage. Voltage is the pressure from an electrical power source that pushes charged electrons or current through the circuit. It is measured using the unit volts, named after the famous Italian scientist Alessandro Volta. His full name was Alessandro Giuseppe Antonio Anastasio Volta. And yes, that is my Italian accent.
Here is how a simple circuit looks like. It has a battery as a power source, wires to conduct electricity, and a light bulb as a resistor. But here's the thing, a real circuit doesn't magically have boxed values on top of your resistors, batteries, and current. You need to measure it. Nowadays, we measure resistance R, voltage V, and current I using a multimeter. But are these numbers related? Yes, it is. The relationship between voltage, current, and resistance in an electrical circuit is Ohm's law. Ohm's law states that electric current flowing through the circuit is proportional to voltage and inversely proportional to resistance. So, in the circuit, if the battery voltage is 9 volts and the current is 0.9 amps, can you calculate the resistance of the bulb in ohms? Well, it's simple. We will use Ohm's triangle to find the missing value. If you want to find the resistance, we divide voltage by current. If we want to find voltage, then we multiply current by resistance. And finally, if we want to find current, we divide voltage by resistance. So, if resistance equals to voltage divided by current, and we know that voltage is equal to 9 volts and current is equal to 0.9 amps, then resistance is equal to 9 volts divided by 0.9 amps, giving us a result of resistance equals to 10 ohms. A few things to remember about Ohm's law. Number 1. Current and resistance is inversely proportional. Number 2, resistance and voltage is directly proportional. And finally, number 3, unit really matters in Ohm's law. Ohm's law will only work if the voltage is in volts, the resistance is in ohms, and the current is in amps. As you can see, when voltage increases, the current also increases. This shows that voltage and current are directly proportional. But if I increase the resistance, the current gets decreased. This shows that current and resistance are inversely proportional. A circuit can also include a switch. This is how the switch looks like when it is off. When the switch is off, it means that the small little part that is circled in red isn't connected to the part that is circled in black. This creates a gap in the circuit, and the gap is nothing but air. Air is an insulator. So, the electric current cannot flow through the circuit, and we call the circuit to be open. Now, there's one last thing that you need to remember. The direction of the conventional current flow and the flow of electrons are opposite. The electrons always flow from the negative pole of the battery to the positive pole of the battery. But this leads to the apparent flow of positive charge from the positive pole of the battery to the negative pole of the battery. But in reality, positive charges, which are protons, do not actually move. This perceived flow of positive charges is the conventional current flow, as we always tend to think in a positive way.
Thank you so much for watching Science with Shriya, and we will see you next time.
Don't mind me, I'm just looking around. Let's see what this kid's got. Uh-huh. She left something. But there's not that much to steal. Oh no! I got an idea.